For this example, in this example, we want to write the standard form of the equation of a circle described. And the equation of our circle should have a center of 0, -2, and it needs to pass through the point -4, 4. So since we want to write the equation in standard form, let's write out what that means. Standard form of a circle is x minus h squared plus y minus k squared equals r squared. And hk, that ordered pair, is the center of the circle, and r is the radius of the circle. So we were given the center, so we know what h and k will be in our standard form. The only part we need to figure out is the radius of the circle. So we want to remember what the radius is. The radius is going to be the distance from the center to any point on the circle. So it's that distance between the center and any point on the circle. Now we were given that our circle is going to pass through the point -4, 4, which means that this point is going to be a point on the circle. So if we can find the distance between our center and this point, that is the radius. We have a formula for distance between points, and the formula for distance between points is square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to take my center, 0, -2, and I'll let that be my first point, x1, y1. And the point on the circle, -4, 4, be my second point, x2, y2. And I'll substitute that into the formula, and that's going to give me the radius. So x2 is -4 minus x1 is 0 squared plus y2, that's 4, minus y1, -2 squared, and all of that is underneath the radical. We're going to simplify using order of operations. -4 minus 0 is -4. And 4 plus -2, sorry, I'm getting ahead of myself. 4 minus -2 is the same thing as 4 plus 2, and that's 6. So we have 6 squared. -4 squared is 16. 6 squared is 36. And 16 plus 36 will give us 52. We want to, well, normally we would want to simplify that radical. Let's go ahead and practice it. The square root of 52 is the same thing as the square root of 4 times 13. And the square root of 4 is 2. The 13 stays inside the radical. But it's much more convenient if we use the unsimplified form when we're substituting into our standard form. So our equation of the circle will be x minus h, which is 0, squared, plus y minus k squared. K is -2. Equals the radius squared. We found our radius to be square root of 52. And then we're going to simplify. I'm going to simplify x minus 0 to be x. I'm going to simplify two negatives multiply to be a positive, and I'm going to simplify the square root and the square canceling each other out. So that will give x squared plus y plus 2 squared equals 52. Now before I wrap this question up, if you did decide to simplify your radius all the way to 2 square root of 13, I want to show how you would simplify that. So if you use the radius as 2 square root of 13, and you had to square that, you would square the 2 and square the radical. 2 squared is 4. The square root squared cancels each other out, and you get 4 times 13, which is 52. So you would get the same thing on the right-hand side, whether you used this format or the simplified format for your radius. So our final answer for the equation of the circle with a center of 0, negative 2, passing through the point negative 4, 4, is x squared plus y plus 2 squared equals 52. In this example, we want to use the graph to determine the domain and range of the function. And we're given this picture of the graph. And one of the very common mistakes that people will make on this type of question is they will only pay attention to these points that are labeled here. And we know that the domain is the set of all the x's, and the range is the set of all the y's. And so some students will make the mistake of writing down the numbers negative 4, negative 2, 4, and 6. But that only gives you these 4 individual points. The domain is the set of all of the x's, so you would be leaving out all of these x's that are in between if you just write down those 4 numbers. So we're going to write the domain in interval notation. And with interval notation, you write down the lower bound and the upper bound, and all of the numbers in between those are included in your set and in your domain. So that way we won't be leaving out any x values or any y values. Now, when I find the domain of a graph, I like to bring out my ruler or my pencil and hold the pencil vertically. And when I hold it vertically, I'm pointing to the x-axis. So I'm pointing to x values. So notice here on this point, I'm touching the graph, but I'm also touching the x-axis at that particular x value. So it's helpful to have this ruler or a pencil vertically to help you notice where your domain starts and stops. So remember, with interval notation, we're looking for a lower bound. So I'm going to start on the left to find my lower bound. And this is the first time my ruler hits the graph. And it's going to help me identify when my domain starts. So my domain starts at that x value of negative 4. I'm going to continue moving that ruler to the right until my domain stops. This is the last point when my ruler is touching the graph, and so my domain will stop at 6. With interval notation, you use either parentheses or brackets on these numbers on the end. We know all of the numbers between -4 and 6 are included in our set, but we need to decide whether the endpoints, are included in the set. So looking at this endpoint here, it's filled in, and on a graph, when a point is filled in like this, it's included in the set, so it should be included in our domain. -4 should be included. We use the bracket when the number is included. On the other end, we have another filled-in circle, and so this endpoint is also included in the set, and so we're going to use a bracket on it. So that gives us our domain. Then we're looking for the range, and the range is the set of all the y values. So I'm going to turn my ruler horizontally. You can use a pencil horizontally. And I'm going to pay attention to the first time I hit my range value, first time I hit the graph. And notice I'm starting at the bottom. The bottom for the y values is smaller than the top. We always write our interval notation from smallest to largest. So that's why we start at the bottom and move to the top. So this is the first time my ruler hits the graph, and that y value is 0. So that's where my range starts. I'm going to move up, and I'm touching the graph. So all of these values are included in the range. And then I get to this point here, and it's the last time that my ruler will hit the graph. So that's where my range will stop. So that's at the y value of 5. So all of the numbers between 0 and 5 are part of the range. That I need to decide whether the endpoints are part of the range. So remember, the lowest y value was here, and you can see that that's a filled-in circle, so that is included in the range and will include 0. And then the highest value in the range was 5. That's also a filled-in circle, so it will be included. So we'll use a bracket. So we have our range going from 0 to 5, including the endpoints. On this example, we're going to use this function on the right to answer the questions for how many values of x is f of x equal to -5, and also what is the value of f of 1. So let's start with that first one. The key thing in this example is that we need to know what f of x stands for. F of x stands for y. So if we read this question again, it says, for how many values of x is y equal to -5? I'm going to take a look at this picture, and I want to go to the y scale and find where y is equal to -5. The y will equal -5 right here. And I can draw a horizontal line, and that horizontal line would represent all of the places where y is equal to -5. Now on our picture, the only one that's a part of the graph is this one right here. So how many values of x? That would be only one value of x has a y equal to -5. For the second question, again, we have to know what this notation means. F of 1. F of 1 is a y. but the number inside the parenthesis is our x. So we want to look on our picture for an x value of 1 and figure out what the y value is. So on our x scale, right here is where x is equal to 1. And if we draw a vertical line, that vertical line is x equals 1. Those are all of the ordered pairs that have an x value of 1, and there's only one ordered pair that has one ordered pair on our graph that has an x of 1. And we need to know what that y coordinate is. You can see that this is a horizontal line. All of the points on that line have the same y value, and that's a y value of -1. So f of 1 equals -1. For this example, it says, for what value of x is g of x equals 7? And we're given this function here that's labeled as g of x. So once again, this is another example where knowing what the notation means is really helpful. So g of x is the same thing as y. This is telling you that y equals 7, and we want to know the x. So if y equals 7, on the y scale, we have a 7 here, and I can draw a horizontal line at y equals 7. That horizontal line represents all of the ordered pairs that have a y coordinate of 7. This point right here is the only ordered pair that has a y coordinate of 7 that's on the graph. So I'm going to look at this ordered pair and figure out what x is on that ordered pair. So that ordered pair is -2, 7. So the value of x is x equals -2. So we could say that g of -2 is equal to 7. So on this example, we want to use the graph to answer the questions, what is the y-intercept of f, and what are the x-intercepts of f? So we have to know what the definition of intercepts are. What is a y-intercept? A y-intercept is where the graph crosses or touches the y-axis. An x-intercept is where the graph crosses or touches the x-axis. Okay, so let's start by looking at the y-intercepts. So the y-axis is this vertical line here. And we're looking for a place when the graph crosses or touches that y-axis. So you can see right here, this point at 0, 0 is where the graph crosses the y-axis. So we would say that the y-intercept is 0. I typically like to write my intercepts as ordered pairs, but for this question in my math lab, they just want the y coordinate. We also want to know what are the x-intercepts. The x-intercepts are where the graph crosses or touches the x-axis. The x-axis is this horizontal axis. And we're looking for places where the graph crosses or touches. So here we have a point where the graph crosses the x-axis. Here we have a point where the graph crosses the x-axis. And here's another one. Now this last point here is a little bit confusing because it looks like it touches the x-axis. But let me erase all my markings so you can see it clearly. This point is labeled with an open circle instead of a closed circle. When you have an open circle, that means that point is not part of the graph. So we only have 3 x-intercepts. So those 3 x-intercepts would be negative 3.4, 0, and 9. So we found the x and y-intercepts using the graph. On this question, we want to use the graph of y equals f of x to answer the questions. And this question is, for what values of x is f of x less than or equal to 0? So there we see f of x again. F of x is the same thing as y. Y is less than or equal to 0. So really what we want to know is, for what values of x is y less than or equal to 0? So on our y scale, anything that is above the x-axis, that's when y is greater than 0, or f of x is greater than 0. Anything below the x-axis has y's that are less than 0, or f of x being less than 0. And then anything that is on the x-axis, that will have y equals 0, or f of x equals 0. So in our example, we're interested in the parts of the graph that are below the x-axis and on the x-axis, because those are the ones that are less than or equal to 0. So I'm going to highlight our graph. I'm going to highlight all of the pieces of the graph that are below the x-axis. And then I want to highlight all of the pieces of the graph that are on the x-axis. And these are all of the x values that we want to include in our answer. And we're going to write our answer in interval notation. And remember, with that interval notation, you want to choose the low number and the high number, and everything in between is a part of the set. So let's see. Since we're going to write down x's, I'm going to hold my ruler vertically. You can hold your pencil vertically. And on this green section here, the first point I hit is this one down here. This is my lowest x. So I'm going to use negative 8. Then my highest x is right here. And that has a negative 15 over 2. I want to decide whether I'm going to use parentheses or brackets on these values. This low number has an open circle, which means it's not part of the graph. So I want to use parentheses and make it not a part of the set. And this one is my high number, and it's a filled in circle, so that should be included. And really, it's, let me rephrase that. It is a filled in circle, and that's important, but not only that, remember that we want to include any points that have y equals 0. So we want to include those points that are on the x-axis. So we're going to use a bracket on that one. Now we're going to do the same thing for our next interval. This next interval, the low is -4, and the high is 5. So our low x is here, and our high x is here, which is 5, and we want to decide whether we're going to use parentheses or brackets. So this number has a filled in circle and it's on the x-axis. We're going to use a bracket. This one has a filled in circle and it's on the x-axis. We're going to use a bracket. And we have one more point to include. So this one is very unique because it's a single point on its own. And when you have a single point on its own, you can't use interval notation. Interval notation is always your low number, then your high number. We always go low to high. So if you have a single number, you can't use this interval notation. So we use a different notation. We use curly braces. So if we have just a single number, we write curly braces. And you're going to union these three things together. All of these together will have y values that are less than or equal to 0. For this example, we want to find the center, radius, and intercepts of the circle, and then sketch a graph of the circle. The equation of the circle is x squared plus y squared equals 100. And this equation is written in standard form. Standard form has x minus h squared plus y minus k squared equals r squared. HK is the center of the circle, and r is the radius. So you can see that since there is no number added or subtracted to the y's, that our center is 0, 0. And because the radius squared is 100, we know that the radius is 10, the square root of 100. We can find the intercepts. We can find an x-intercept by letting y equal 0. That would give the equation x squared plus 0 squared equals 100. That simplifies to 100 equals x squared. We're going to square root both sides. And we get x equals plus and minus 10. We've got two x-intercepts, positive 10 and negative 10. You can do the same thing with the y-intercepts. You find a y-intercept by letting x equal 0. That would give the equation 0 squared plus y squared equals 100. That simplifies to be y squared equals 100. We can square root both sides. And we get y equals plus or minus 10. So we have y-intercepts at positive and negative 10. Then we want to sketch the graph of the circle. So we find where the center is. The center is 0, 0. And the radius is 10. So we're going to go 10 up, 10 right, 10 down, and 10 left. And that gives us some points on the circle. And from there we can sketch the rest of the circle. So we have the center at 0, 0, a radius of 10, x-intercepts of positive 10 and negative 10, y-intercepts of positive 10 and negative 10, and a sketch of our graph. So for this question, we want to use the graph of y equals f of x to answer the question. For what values of x is f of x less than or equal to 0? So f of x being less than or equal to 0 means that y is less than or equal to 0. On our graph, we're looking for portions of the graph that are below the x-axis or on the x-axis. So let's highlight that. This section is below, and we have endpoints that are on the x-axis. And then we have this point here that is on the x-axis. So everything that I've highlighted in green has a y value that is less than or equal to 0. So I want to write which x values have y's that are less than or equal to 0. So for this section right here, I want to use interval notation. I want the lowest x and the highest x. That creates my interval -6 to -11 over 2. And I have an open circle, which is not included in the graph, so I use a parenthesis on that x. And I have a closed circle, which is included, so I'll use a bracket on that one. Then I want to write this interval, and that interval starts with an x of -2 and stops with an x of 7. So that's our interval, -2 to 7. And we're going to use brackets on both of these because both of these are included in the set. And then we have one more point which we need to include. This has a y coordinate of 0. And we can't use interval notation on that. So we'll use curly braces for an individual point. So the intervals of -6 to -11 over 2, including -11 over 2, -2 to -7, including both -2 and 7, and 11, all have y values that are less than or equal to 0. So on this example, we want to find the center, radius, and intercepts of this circle. And we also want to sketch the graph of the circle. The equation we're working with is 2x squared plus 2y squared minus 4x plus 8y plus 2 equals 0. So this is the equation of the circle, and it's in general form. The first thing that we want to do is turn it into standard form. And standard form is a lot better for us because we'll be able to identify the center and the radius once it's in standard form. So with this example, there's an extra little step that we're going to do at the beginning. Because we have coefficients on our x squared and y squared term, I'm going to get rid of that first. So I'm going to divide every term by that coefficient to clear it out. So that would give me x squared plus y squared minus 2x plus 4y plus 1 equals 0. And then I'm going to start to make this equation look more like standard form. Standard form has your x's grouped together. So I'm grouping the x squared and the 2x. It has your y's grouped together. So I'm grouping the y squared with the 4y. And I also want this constant, the 1, on the other side. So I'm going to subtract 1 on both sides. So now that I've got the x's grouped together, the y's grouped together, and the constant on the other side, I want to find the magic number for each group. Now the magic number is what is going to make our x group factor to be a perfect square, and our y group factor to be a perfect square. This is a process called completing the square. So in our x group, we want to find the magic number. And so what we do is we start with that coefficient of the x term. We start with -2. And we're going to do a calculation with this number. We divide by -2 and then square it. Oops, I'm sorry. I misspoke there. We start with -2. And we cut that number in half and then we square it. -2 divided by 2 is -1, and -1 squared is 1. So our magic number for the x group is 1. Then we want to find the magic number for the y group. And similar process, but we're going to start with the coefficient of the y term. We start with 4. We cut that in half and square it. 4 divided by 2 is 2. 2 squared is 4. So the magic number for the y group is 4. Then we're going to add these numbers to the x group and to the y group. I'm going to add a 1 to the x group, but I need to balance the equation by adding a 1 to the other side. I'm going to add a 4 to the y group, but I need to balance the equation by adding 4 to the other side. I'm going to factor the x group. X times x is x squared. 1 times 1 is 1. And I need to create that -2 in the middle, so I need minuses. And this factors to be x minus 1 squared. I'll factor the y group. Y times y is y squared. 2 times 2 is 4. And I'll do pluses to create that 4y in the middle. So that factors to be y plus 2 squared. On the right-hand side, -1 plus 1 plus 4 would give me 4. And now I've written the equation in standard form. Now that it's in standard form, we can identify the center and the radius. The center is 1, -2, and the radius is 2. We also want to find the intercepts. Now it's going to be easiest to find the intercepts using our standard form. So let's do that. Let's find the x-intercept by letting y equal 0. This gives me x minus 1 squared plus 0 plus 2 squared equals 4. This will simplify to be x minus 1 squared plus 0 plus 2 is 2. 2 squared is 4. We want to solve this equation by isolating the square. So I'm going to isolate the square and everything that's attached to it. I'm going to subtract 4. That gives x minus 1 squared equals 0. I'll square root both sides. That gives x minus 1 equals 0. I'll add 1 to both sides and I get x equals 1 as my x-intercept. I'm going to do this again, but this time looking for the y-intercept. Find the y-intercept by letting x equal 0. That would give me the equation 0 minus 1 squared plus y plus 2 squared equals 4. We'll simplify. 0 minus 1 is negative 1. Negative 1 squared is a positive 1. I'm going to solve by isolating the square and everything that it's attached to. So I'll subtract 1 on both sides. This gives y plus 2 squared equals 3. I'll square root both sides. The square root and the square cancel each other out. And I get that plus or minus symbol on the other side. Then I'll subtract 2. And I have my y-intercepts being negative 2 plus or minus square root of 3. One final thing that we want to do on this example is to graph. So let's get a grid for us to draw our graph on. And our circle has a center at 1, negative 2 with a radius of 2. So from that center I'm going to go 2 up, 2 right, 2 down, 2 left, and that gives me a graph of my circle. And what's nice about this is that this confirms what we saw with our work here. We found just one x-intercept at x equals 1. You can see there's that x-intercept. And we found 2 y-intercepts. Here you can see we have 2 y-intercepts here. So we found the center and the radius by converting our equation from general form to standard form. Then using standard form we found the x and the y-intercepts. And using the center and the radius we were able to sketch a graph of the circle. So for this example, we want to classify the given function as a polynomial, a rational, or a root function, and then find the domain. We want to write that domain in interval notation. The function that we're working with is g of x equals the 6th root of 8 minus x. Now to start off this problem, we do want to classify as a polynomial, a rational, or a root. Now there are very technical definitions for these functions, but we're going to just jump right to the point and just get a practical way of identifying what type of function this is. For a rational function, you're going to be looking for a fraction bar with a variable in the denominator. For a root function, you're going to be looking for a square root, or maybe a cube root. Pretty much everything else is going to fall into the category of polynomial. Of course, it's more technical than that. Polynomials will have your variable raised to a nice power. The power would need to be a whole number. Whole numbers are numbers like 0, 1, 2, 3, and so on. So this one, you can see, because we have the sixth root, we have that radical symbol, we know that this is a root function. But we also want to find the domain of this function. And we want to categorize this root function as either even or odd. So you look at the index, and we have an index of 6, which is an even number. So we would classify this as an even root. Now, when you have an even root, you do have some restrictions on the domain. For example, if you were to calculate the square root of -1, you would get I. But if you were to calculate the cube root of -1, you would get 1. So here you see an example of why we have a restriction on our even roots. When you have an even root of a negative number, you get an imaginary number. And when we're finding domain, we want to find only values that produce a real number, not an imaginary number. So what we do is we take the expression that's underneath the radical, and we want to avoid the negatives. The way we avoid the negatives is we say we want it to be greater than 0 or equal to 0. If we solve that, this is how we're going to avoid those negatives underneath the radical. So I subtract 8 on both sides. That's -x is greater than or equal to -8. I'll divide both sides by -1, and that gives x. I'm going to reverse the inequality symbol because I divided by a negative. And -8 divided by -1 is a +8. This is our domain. This is how we avoid having a negative underneath that even root. So on the number line, 8 would be marked, and we would shade everything below 8. Our interval, our low bound, would be -infinity, and our upper bound is 8. And we would have a bracket on the 8 because we're including that 8. So the domain of this even root is -infinity to 8, including 8. Thank you for checking out my videos. Have a great day.